Jacob Biting. I'm the project manager and lead designer. We are doing a blended wing aircraft, not too dissimilar from the Boeing X-48B. A blended wing body, or BWB for short, is an aircraft designed with a flattened fuselage, often in the shape of an airfoil, which produces significant amounts of lift. They have high lift-to-drag ratios, or L/D, due to the lifting body. We are designing this because trade studies have shown that L/D can be up to 50% higher than conventional designs.
Hello, my name is Rahman Abdul. I'm the structural and layout engineer. Our aircraft has 3 different boxes for economy, two different boxes for business, and 2 different boxes for first class, with 104 on the 2 sides on the economy and 105 in the middle, and 40 and 40 in the business, and 23 total, with 11 and 12 in first class, with the storage in the bottom being exactly the same as the Boeing 747, with rearranged the plats of how it goes on our aircraft.
I'm Evan Johnston, the Energy and Propulsion Systems Engineer for this project. I've been tasked with doing a parametric analysis to design an engine for the aircraft. We need to achieve 44,000 newtons of thrust with 3 engines for this design, and we have to maintain a range of 11,260 kilometers as part of our customer requirements. With the current iteration of the engine design, we've been able to achieve 36% reduction in fuel consumption over the Boeing 747. The images shown here depict weight distribution and lift generation. The image on the left is the Boeing 747-400. The arrows in purple show the weight of the aircraft downward. The arrows in aqua show the lift force keeping the airplane aloft. Practically all of the weight load in purple is at the center of the aircraft, and almost none of the aerodynamic lift is in the center. Our blended wing X-Jab aircraft on the right has the weight in purple more evenly distributed. This, along with other factors, lead to a safer and more efficient aircraft. Shown here is a typical 5-hour flight from Atlanta to Los Angeles. A Boeing 747-400 would burn 18,000 gallons of fuel in this flight. Our X-Jab aircraft would consume 11,500 gallons for a savings of 6,500 gallons of fuel. In this cross-country flight, using only the fuel saved by the X-Jab aircraft, we could fly from Kansas City to anywhere in this green zone. If X-Jab flew on average of 3 of these flights daily, for a single year, it would save 6 million gallons of fuel. This would be more than enough to fill this 5 million gallon water tank in Fort Worth, Texas. This equates to a savings of $13 million annually.